In this video, I'm going to show you how to solve problem number 1 on the gram-to-gram stoichiometry 2 problem set that you received on Wednesday, February 3rd, 2016. Let's read the question. A student lights the propane gas on his grill and burns propane, C3H8, in the presence of excess oxygen gas. If the student burns 100 grams C3H8, how many grams CO2 will the student release into the atmosphere? All right, so let's get started. We're going to need a known and unknown table. All right, and with our known and unknown table, we always start off with what we don't know. So I go back to the question that asks how many. Let's see, it says how many grams CO2. So we're going to have to find an answer or calculate an answer that ends with the units of grams CO2. All right, so that's going to be our unknown. What are some of the things that we know? Remember, we're going to need 4 numbers when we're solving gram-to-gram stoichiometry problems. The first number always comes from the problem itself. 100 grams C3H8. So that's something we know, so we're going to put that into our known table. The second number that you need with gram-to-gram stoichiometry is a molar ratio, and we use the balanced chemical equation to figure that one out. So in the problem, we care about C3H8 and CO2. So we go to the chemical equation, we look at the coefficient in front of C3H8, it's a 1, and we look at the coefficient in front of the CO2, it's a 3. So it's a 1 mole C3H8 to 3 mole CO2 molar ratio. We're going to write that down in our known table. The third and fourth numbers that you need in the gram-to-gram stoichiometry are the molar masses of the chemicals that we care about. So we care about C3H8 and CO2. So we're going to have to calculate the molar ratio. Here's kind of another little tutorial on how to do that. So let's get that started. So I'm going to write down molar mass C3H8. All right, so the C3, the 3 is the subscript. That means that we have 3 carbons. Let's see, the molar mass of, the atomic mass of carbon is 12. I have 3 of those carbons, and so I'm going to write this out, right? Think about it, I have 3 of them, so I'm going to need 3 of those. 3 carbons, 1 carbon is 12 grams per mole. Multiply that by 3 to get the total molar mass of just the carbon in propane. All right, let's see, hydrogen has an atomic mass of 1. All right, so we're going to write that down. But look, the subscript is an 8. So we have 8 hydrogen atoms, each with an atomic mass of 1. So we're going to multiply that atomic mass by 8. And let's see, order of operations says that we have to multiply everything before we add. So 3 times 12 is 36. 8 times 1 is 8. 36 plus 8 is 44 grams C3H8 per mole C3H8. And notice how I put the units are labeled with the actual chemical's name. I'm going to put that into the known table. All right, and now I'm going to just make some more room for myself. Let's do the molar mass of carbon dioxide. Okay, so there's carbon, there's oxygen on the periodic table. The atomic mass of carbon is 12. That means the molar mass of carbon is 12. I'm going to write that down. Note how the carbon in CO2 doesn't have a subscript, so it's implied that there's just 1 carbon there, right? So let's do oxygen next. We're going to add the 2 oxygens. Let's see, the atomic mass of oxygen on the periodic table is 16. I'm going to put that down. But CO2 has 2 oxygens, and so I'm going to multiply that 16 by 2. Order of operations says we have to multiply the 2 times 16 first. So 12 grams per mole plus 32 grams per mole equals 44 grams CO2 per mole CO2. And I label those units. I'm going to put that into my known table. All right, let's erase this again. Perfect. Okay, let's move forward. So I'm looking for an answer that ends in grams CO2. And so I'm going to go over to my known side and I'm going to find that unit. There it is, G CO2 over mole CO2, right? That's my first fraction. The gram is already on top, so I don't have to flip it. I'm good to go. But now I have to get rid of that mole CO2 on the bottom of that fraction. So I come back over to my known side and I find that unit. There it is. It's in my molar ratio. But notice how that mole CO2 is on the bottom of that fraction. So I've got to flip it. 3 moles CO2 over 1 mole C3H8. Now I've got to get rid of that mole C3H8. So I go back to my known table. There it is. The mole C3H8 is on the bottom of that fraction for the molar mass of C3H8. It's on the bottom, so I've got to flip it. We're manipulating the numbers to what we want them to do, right? Trying to cancel everything out. Okay, finally we have to cancel out C3H8. So I come back over here. I find that unit. There it is. Multiply it. I make that look like a fraction by putting it over 1. All right. Now my favorite part is to cancel out those units that can be canceled, leaving us GCO2 all the way on the left there. Okay, order of operations says we have to multiply everything before we divide. So we multiply all the numbers on the top, all the numbers on the bottom separately before we divide. All right, so 44 grams CO2 times 3 times 1 times 100 over 1 times 1 times 44 times 1. When you do all that math in the calculator, it's equal to 13,200 grams CO2 over 44. This is now a division problem. We always work from the top down when we put the number into the calculator. So 13,200 divide sign 44 is equal to 300 grams carbon dioxide. Challenge yourself, watch the video again. It's a very, very meticulous process. It's the same process every single time. In fact, if you watched the other videos yesterday, you saw that every single time I do this, it's the same script. In fact, it's always the same order of the numbers. Have you noticed that? Look, this number is always right there. It's always a molar mass. This number is always a molar ratio. This number is always a molar mass. And this number right here is always the final mass, rather the mass discussed in the question itself. It's always the same thing. It's just that the numbers are different. All right, so I'll be back tomorrow on Thursday to answer any of your questions.